take a look at page 96. So last time we went over the 3 laws. One is about multiplying, right? And then dividing, and then also the exponent, right? Exponent, you can put it to the front. So just make sure you pay attention to the one in the red bracket right now, right? We don't have rules for dividing log separately, okay? So if you are multiplying or divide, it has to be inside the log, right? So let's look at number 4 now. Number 4 is called the change base rule. So what it does is you can choose your own base, okay? And then depending on the question, right, you can choose the base that's useful. There we will have question that needs to use change base, then you will know what I mean, okay? So first we'll go over where this rule come from. So let's say we start with y equals, not y equal log BA, okay? And I will call this equal to m first, okay? And then I would like to change this into exponential form. Right? Can you do that on your page? Okay, turn this into exponential form. So Kelly, what does it look like? Have you watched the video from last class?
Yeah, I have.
Yeah, okay, so you know how to change to exponential, right?
I think so, yes.
Okay, so what does it become?
B exponent m equals a.
Yeah, very good. Okay, you just go counterclock, right? Always starts from the base and then go to the other side and then get the exponent, right? So, okay, so now this is exponential form. And then what I'm going to do is I'm going to put log on both sides. Okay, a similar idea to you can square both sides to get rid of square root, or you can square root both sides to get rid of square, right? You do the same thing on each side, then they will remain equal, right? So I'm going to put log on both sides. So it will look like this, log, right? And log, and then b to the m, a, right? So it's log being placed on both sides. And this log, because you get to choose, right? You put it on by yourself, so you get to choose any base you like. So I'm going to choose a base of c, right? Log base c. Okay. Now after that, you on the left side you have an exponent, right? So we have the previous rule, number 3, the exponent, right? Exponent n, I can put it to the front, make it look like a coefficient. So the m, I can put it to the front. All right. So I will have m. Okay, let me draw a line. Okay, m will go to the. Okay, let me erase that. Okay, so after we put a log on, we bring the m down. So log base c of b. Right, log base c of a. Any questions so far? And then we are going to isolate the m. Okay, how do we isolate the m? Ray?
What?
How do we isolate the m?
You divide
Divide by?
log CB.
Yeah, okay, so both sides divide by log base c of b, right? So m will go, the log b will go to the denominator. So you will have m equals to log base c of a over log base c of b. And remember what the m was before. right? Look at the yellow highlighted. M was the log base B of A, right? So which is the M there, right? So I'm going to replace the M back, right? So it will look like log base BA equal to log base CA over log base CB. Okay, so that is the formula that we have here. So the base C is the new base that you want to choose. You can use any base you want, right? And just remember the A goes to the numerator and B goes to the denominator, okay? And then you can choose any base you like, all right? So for example, you can put it down here. So let's say if I want to find log 2, okay, let's use something else. Log 4, 8. Right? So this one, if I try to do counterclock, right? And then we think about 4 to something has to be 8. It's more difficult, right? It's doable, right? You can turn into exponential and then solve for it, right? But we could also use change base to help us, right? So what would be a good choice to be the new base? Donna, what do you think? The 4 and the 8, they both has to do with which base?
2.
2, right? So we can choose the new base to be 2, okay? So I can write log, the new base is 2, right? Log, new base is 2. So what number goes on to the top? Tiana?
8.
Yep, 8 will go to the top, so 4 will go down. So now because they both have to do with base 2, right? So it's easier to do it now, right? So for the top, we can do counterclock. So what's the answer for log base 2 of 8? Eric?
3.
Yeah, okay, so top will be 3. And what about denominator? Kelly?
2.
Yep, so equal to 2. Okay, so your answer will be 3 over 2. Okay, for log base 4 of 8, right? If you try to do counterclock with the original question, it takes more time. But if you change base, right, then it will work. Okay, and you can double check, right? To check, you just write 4 to the 3 over 2, right? And see if it equals to 8, right? It should equal to the 8. Okay, so next rule that we have is this one, okay? Number 5, base to base. So the unique thing about this one is this base and the base for the log are the same, okay? Has to be the same for this to work, okay? So you had a little, you had one question, I forgot the number. I think it was 37, maybe? Was it 37? Okay, has to do with this one. So for example, right, if I have 2 to the log base 2 of 5, based on this formula, what does it equal? Ray? Ray, are you there? Is your Wi-Fi working? How about Tiana? What's the answer for this one?
5.
Yeah, okay, so it will just equal to 5, right? Whatever after the base, after the log, it will be the answer overall, right? So this one is a 5, so you get an answer of 5. Okay, so let's show why this formula works. Okay, how come base to base or equal to the t, right? So let's say we start with b and log bt, right? So that was the question. I want to find out what this equals. So I'm going to just put an empty box, right? That's a question mark. We want to show that it will become t, okay? So I'm going to borrow the same way that we did on the last log. I'm going to log on, okay? Again, log on both sides, okay? So I will put the log on the left. So log on the left and log on the right side, okay? And then I'm going to choose the log I put on, okay, the base. I'm going to choose the base b, right? So the left side, we would have b to the exponent of log base bt, right? Looks a little bit complicated now. And then right side will be the empty box, okay? Just like before, right? We put a log on both sides. And then same thing as last time, right? We can also now bring the exponent down, right? Just like the m, we took the m down, right, to the front. So now what we have on the front, it will be log base b t, right? And then the red one, log base b of b, right? Now you just have b inside because the exponent goes to the front, right? And then right side, we would have log base b of the empty box, which is what we want to find. All right, so let's take a look here. What is log base b of b? What's the answer for the middle one? Cindy?
One.
Yeah, very good. Okay, b to the 1 will equal to b, right? So the whole thing just goes to 1. So what you are left with is just log base bt equal to log base b of the box. Now they both have log, right? So of course I can log off, okay? So I can take the log away. So t is the empty box. And we are trying to find the empty box, right? At the beginning. So we found out it has to equal to t. Okay, makes sense? But of course, if you try to do this every time when you get a question, right, it takes too long, right? You have to log on both sides, simplify, right? So just remember this special question, right? When you have same base, whatever that comes after the log is your overall answer, okay? All right, number 6 is the reciprocal, okay? Reciprocal rule. So what this one is saying that if you swap those two, right? Base is B here, right? On the left side. Now on the right side, let me use a different color, right? The base becomes A, right? Used to be the big number. Now it becomes the base. Used to be the base, it becomes the big number, right? After the log. But then you need to do 1 over. All right, so let's also look at an example. And then we could take a look at how this can be applied, right? So for example, if I have log, let's do 8 and 2, right? Base 8 of 2. So this one, if I want to find out what this equals, right? Of course, you can do counterclock. 8 to something equals to 2. Okay, 8 to what exponent can become 2? Think about it. Elaine, what do you think the exponent should be?
A third.
A third, right? So a third is like a cube root, right? Very good. So now let's see if the formula also can give us a third, okay? So I'm gonna take away the counterclock now, right? And then apply the formula. So the formula tells us to put 1 over, right? And then we will swap the base and the big number. So it become base 2 of 8. And then the denominator, this one is easier to do now, right? 2 to the 3 will be 8. So we know the denominator will be 3, so 1/3, a third, right? So this also shows us this works, okay? So you can, depending on the question, if you feel like you want to swap it, right? You can do that, right? Just make sure you put 1 over, all right? Now let's try some question, okay? In the homework, you've done questions similar to that, so I'm going to just let you try question D, okay? Question D is the one that got to do with the new law that we just learned, all right? So I'll let you think about this one. Your goal is to evaluate. Evaluate meaning the final answer is just a number, okay? No log at the end. So let you try this. And once you get the answer, or if you get stuck, okay, also raise your hand, okay? So I know we can start going over it. Is there anyone doesn't know where to start, like what to do first? Let me know, okay? I can give you some hint. All right, I would like to know what you guys did on your first step. So Kelly, can you tell me what you've done so far? Kelly?
Oh, sorry, me.
Yeah. Did you do anything so far?
Can we bring the exponent down to the other side?
Which exponent?
Both of them?
You mean this whole thing?
Yeah,
Bring it down?
yeah.
Okay, you can only do that if there's a log, right? If
Oh.
there's a log at the front, then you have rule number 3 to bring it down. But there's no log here, so you can't. So what do you think? What else can we do?
Rule number 5.
Rule number 5. Okay, rule number 5. Let's take a look. Rule number 5 needs to have a base, right? Oops. Okay, you need to have a base here and then 1 log on the top, right? With the same base. Then you can use rule number 5. Now, if you look at the question, right? You have base of 7, and how many log are there?
2. 2.
2, right? Yeah, so you cannot use it yet. You have to somehow make it into just 1 log first. Okay, so your goal, your focus right now is you should focusing on the exponent, how to make it into 1 log. And that's what we did learn last week, last class, how to turn it into 1 log. Do you know how to do that?
I did.
Huh? What did you say?
Huh?
Do you know how to turn it into 1 log?
Yeah.
Yeah, okay, so I'll let you try, okay? So let me know when you get 1 log, okay? So it will be 7 and then log something, okay?
Okay.
7, right? So let me know when you have the something. Cindy, are you done? Okay. You got it? Kelly, any questions?
Is it log 7 to the 3?
7 to the 3, log 7. Oh, you mean inside is 3?
Yeah.
No, can you tell me what you did though? Just focus on the exponent right now. Can you tell me what you did? Which rule can you apply?
The quotient.
Quotient. Yeah, there's a quotient rule, right? That's number 2, right? But you can only use number 2 if the log, okay, look at number 2. The log is clean, right? There's nothing in front, right? Log something, subtract log something, right? Nothing in front of the log. But over here, you have something in front of the log, right? What's the number in front of the log?
2.
Yeah, so you got to take care of that. And which rule can you use?
Log of power.
Yeah, so how do you use that?
You bring it to the
To the,
to the sorry.
look at rule set 3, right? If there's a number in front of log, where can you put it?
You bring it onto the other side of log.
You bring it to the exponent, right? Do you see the n?
Yeah.
Right? And if it was in the exponent, you can bring it to the front. So if it's in at the front, you can bring it back to the exponent. Make sense?
Mm-hmm.
Yeah. So over here, so where should we put the 2?
Where the 3 is.
So 3 to the What?
3 squared.
Square. Okay, continue. Tell me what to write. Minus.
Log 7, 2.
Yeah. And then what do we do next?
Log of quotient.
Okay, how do we do that? Log.
3.
Base. What's the base?
7.
Yeah. And then
3 squared over 2.
yeah. And what's that?
9 over 2.
Yeah. Log base 7 of 9 over 2. Okay, so the whole exponent, the red part, is going to be 7 over 2, 9 over 2 on the inside. Got it?
Yeah.
Okay. So now this is the, now it looks like rule number 5, right? You have the base of 7 and the exponent also has a base of 7, right? So your final answer should be what? Donna?
9 over 2.
Yeah, okay. So it will just whole thing equals to 9 over 2. All right? So even though it's using rule number 5, but then they won't just give you a simple question, just you apply it, right? Sometimes they mix other rules, right? For you, you got to take a few other steps first, okay? To see if you remember how to apply other laws. Okay, so now let's look at another types of questions. Page 98, okay? This part is not evaluating, okay? Because if you look at the value that they give you, right? Log 5. Okay, there's no base there. So what's the base for that one? Ray? What's the base for log 5 here?
10.
Yeah, okay. Remember, if you don't see it as 10, right? So it tells you that log 5 is k. Log base 2 of 7 is m, right? So it doesn't give you a number. So the question wants you to determine an expression, right? So it's not finding a value, it's not evaluating. So at the end, your answer for these questions, it will be in terms, it will have variables inside, not variable, letters, okay? So of course, you got to break it down. You have to see the log 5, right? You make it appear, then you can replace it with k, and then you make log base 2 of 7 appear, then you can replace it with m, okay? So let's go over one question together, then you'll know what I mean, right? So for this one, of course I see 5, right? But this is not just a 5, it's a square root of 5. So I cannot just replace it with k yet, okay? So you need to think about the 6 laws that we learned. Which law can we apply first? So Tiana, what do you think? How do we start? Which rule to use? Tiana, are you there? Which rule do you think we can apply first? What do you see in the bracket?
Quotient?
Quotient, right? Yeah. Inside the bracket, you see a quotient. So how do we apply it then? What does it become?
Log 10 root 5 and
Okay.
minus log 10 to 1000.
1000, yeah. Okay, so if it's 10, then we don't need to write it out, okay? You could just say log 1000. Then I would know it's a base 10, all right? Now we have two terms here, right? But still, I cannot just say, okay, there's a 5 and I'm going to replace k yet, right? It has to be just log 5 itself. Then I can write it as k. So what else can we do? What other rules can we apply next? Cindy? Cindy?
Hi.
Hi. How can I apply the rules so then the log 5 can appear?
Make it like 5 to the power of 1/2.
Okay, so write it as exponent, okay? And then what?
10 to the power of 3.
Which one?
Like the 1,000.
Oh, 1000 there. Okay, we'll worry about that later. Okay, right now I want to focus on this part. 5 to the, what do we do now?
1/2 log 5.
So which law did you use? Number what?
The moving it one. 3.
Number 3. Yeah, very good. Okay. So now once you get to this step, then you can see that there is the log 5, right? So only when it's by itself, then I can replace with a k, okay? So it become 1/2 k minus, okay, now here log 1000. I think Cindy already gave it away, right? Because this one we have a base of 10. So 10 to the something is 1000. 10 to the 3. So your final answer is the 3 at the back, okay? So your final answer will have no log, okay? Then that's the expression that we want to get, okay? So for each of the question here, we don't want to have any log as your final answer, right? You need to somehow simplify it. So I'll let you try question B now. Okay, so that's what this means, right? You have to apply the rules that you think is needed and then break it down into add and subtract. And then once you can see the log 5 or the log base 27, then you can replace it. Okay, so if you get the answer for B, please raise your hand, okay? Or if you get stuck. So clearly here, right, it's again got to do with k, right? Everything has the related to 5. And you can also think about question C, okay? But if you finish B, please raise your hand. Okay, I would like to know the first step that you took. Okay. Eric, can you tell me what you did first?
I changed it to log 125 minus log 5 root 5.
Like this?
Yeah.
Yeah, okay. All right, and Donna, did you do the same thing?
Yeah,
Yeah, okay. Can you tell me what you did next?
I changed 125 to 5 to the power of 3.
Okay, I'm gonna take one step more, right? So I'll bring the 3 to the front.
Yeah,
Okay. And then?
and then
Yeah,
log
log
5,
5.
and you can put 2 square root 5.
2, what do you mean? 2 square root 5?
No, square root of 5.
Oh, copy again? You didn't do anything for that?
Yeah, you could do it in
Can you tell me what you can do with the 5 square root 5?
5 to the power of 1 over 2.
5 to the 1 over 2 is the square root 5, right?
Yeah,
How about these two? Can we multiply them together
yeah.
into what? How do we simplify inside the brackets? Did you
You can
multiply them together?
do
Say that again.
5 to the power of 3 over 2.
Oh, 5 to 3 over 2. Okay, very good. All right, so this one is 5 to the 1, and then the other one is 5 to the half. You could add the exponent together, right? So you get 5 to the 3 over 2. Okay, so that means I can also do the same thing, take one step faster. I'm gonna bring the 3 over 2 to the front. All right, so now you can see it's a log 5 here, right? Another log 5 there. Now we can replace it with the k, right? So we would have 3k minus 3 over 2k. And they are like terms, right? They are both k, so we can subtract them together. So what's the final answer then? Kelly?
Three over 2k.
Yep, so at the end we get 3 over 2k. Okay, so this one it doesn't have any number at the back, okay, because it doesn't have something like log 1000, right? So it's just something k. Okay, any questions? Anyone got different answers? Okay, for this one, there's a different approach for this one, okay? So what you could also do, right, is try to simplify the inside first, right? Because you can see the inside, every number has to do with base of 5. So you could simplify the inside, so then you make it look like log, and then 5 to the something, right? Doing the same base thing, right? And then once you get to that point, I believe it should become 3 over 2 in the box, and then bring it down to the front, okay? That's another way to go. Okay, so let's look at question C. Okay, question C, you have an 8 base of 8, right? You also have a 49, right? So do you think this question has to do with the K or the M? Ire?
The M,
Has to do with M. How do you know? What makes you think that?
because like 2 and 7 are factors of 8 and 47.
Okay, yeah, that's another way to think of it. Yes, very good, right? 2 can somehow connect with the 8, right, with the exponent. 7, right, is also divisible into 49, right? It's a factor of that. And also another thing is the 5, right? Log 5 doesn't have base of, right? It has a base of 10, right? So it's not, it's more unrelated to this one. Okay, so now if you want to use the M, it has to be base of 2. But then over here we have base of 8. That makes it impossible to turn it into M. So which rule can help us solve that problem then? Make it into base of 2. Which rule can do that? Cindy?
Um, 3, I don't know, the one that changes it to the exponent, right?
Changes to the exponent. What do you mean changes? Let's look at the rule. What do you mean change? Which one? Number 1, 2, 3, 4, 5, 6. Which one?
Three.
Number 3. Number 3 is saying if you have an exponent, right, inside the log, you can bring it to the front.
Oh,
Okay, do we
like-
have exponent in the log?
like I know what you do for it. I don't know which rule to pick.
What do you mean?
Like it would change it to like log base 2 to the power of 3, right? That's how you get the base 2.
Log base 2 of 3.
Right?
Where's this come from? Can you explain to me?
I don't know. I just changed the 8 to 2 of 3 because that's what it equals, right?
You mean you change the 8
Yeah.
into this?
Yeah, because 8 equals 2 to the power of 3.
Okay, 8 is 2 to the power 3, but why do you put a log?
Because it was at the front.
At the front? I know 2 to the 3 is 8, right?
Yeah.
Yeah, so I don't understand why you say log 2, 3 is 8.
No, like log base of like the base is 2 to the power 3 equals log base of 8.
Oh, okay. So you mean you want to write it as log base 2 to the 3 and then 49, like that?
Yeah.
Oh, okay. That's the same. They are the same, but then this looks quite complicated, right? You have a little exponent in the base.
Oh,
So,
but then you get 2.
huh?
But then you get a base of 2, like something with a 2.
Oh,
Have-
something with the 2. Yeah, yeah. But then what are we going to do with the 3 then, the base, the little exponent, the tiny exponent?
I don't know.
Well, think about the question I asked initially, right? Because we want to have base of 2. But then the question has base of 8. Take a look at all the rules. Which one can help us make the base change? Cindy, it's still you. I'm asking you.
Mm, Um,
Did you hear my question?
which rule to choose?
Okay, we want to use m. What's the base for the m?
2,
2, right? And the question has base of
8.
8. So we want to make the base change, right?
Oh, 4?
Yes, okay. So we have to use base rule number 4 because that's called change base rule. Okay, so what base do we want to change to?
Still me?
Yeah, still you.
2.
Okay, can you tell me how to turn into base 2 now using rule number 4?
Log 849.
Huh?
Like
Copy again?
equals
Oh,
the
cool. Okay.
I just say the next part. Okay, never mind.
You already have the question.
Log 2 and then 49 over log 2 8.
Yes. Okay. Yeah, you can. That's it. Okay. Very good. So far, right, you changed the base. Now we solve the problem of having different base. Then you can go from there, try to somehow make the 7 appear, right? Because in order to use the m, we have to have 7, right? And then the denominator, right? Think about what to do there, right? So when you get the final answer, please raise your hand. So when you get a question, you always think about what's the problem, right? What's making it difficult? So the thing that's making it difficult is it's having a different base, right? So that's where you start thinking, right? How do we make this easier, right? And then because we want to have a new base of 2, then you think about, okay, the only rule that can help us change base is number 4. Then you apply rule number 4. Right? Because you have a list of tools, right? You got to know how to choose which one to use. Okay, so Elaine, can you tell us what's your next step from here?
You make the top equal to 2 log base of 2 and 7.
Okay, and denominator?
3.
3. Okay, very good. Okay, 49, you can write it as 7 squared. So rule number 3 can bring down the exponent. So now you would have the log base 2 7, right? The green circle. So you can replace it with m. So it'd be 2m over 3. So that's your final answer, right? That's an expression. Right, so similar, okay, similar, I'll let you try question D. Okay, this time by yourself. If you have question about C, you can let me know, okay, any step not clear. So question D is similar, also has 7, right? This one is clearer, right? They all got to do with 7. And also the base, right, has 8 and 16. That also needs to be changed. Okay, so please raise your hand if you also finish this one. So your very first step is to make all the base become 2, okay? That's your very first step. Okay, Eric, can you tell us how you change the base? How to write it?
Do you use number 4?
Yeah. And what does it become after you use that?
Log 2 root 7 over log 2 root log 2 16.
Okay, and then?
And then minus log 2 1 over 7 squared.
Oh, so you bring the 2 back, is it?
Am I supposed to?
Up to you. Doesn't matter. You could leave it at the front or bring it back.
Oh.
We could put it at the front. We can do the 2 later. Okay.
Okay.
Yeah. We'll leave the 2 at the front.
Oh. Okay. So then it's log 2 1 over 7 over log 2 8.
Yeah. Okay. Very good. Okay. So either way, right? You could put the 2 as square. I would prefer to leave it at the front, right? So you don't have exponents. All right, so after that, keep going, all right? So let me know when, raise your hand if you finish the whole thing. Okay, I want to check the first fraction on the left side. I want to see what you did for that part, the first fraction. Tiana, did you do anything for the first fraction?
For the numerator is 1/2 log 7 over 4.
1/2 log 2 7 and then over 4 like that.
Yeah.
Yep. Okay. Very good. Okay. Now for the second fraction. Okay, Donna, do you have something for the second fraction?
Log base 2 of 7 to the power of -1 over 3.
Okay, over 3. Now the -1, we can bring it to the front. Okay, so I'm gonna bring it down. So negative. Okay. Okay, so I think once you get here, it's pretty much almost done, right? Because you can see the log base 2 7 here. You can also see another log base 2 7, right? Only when you can see those two alone, then you can start replacing it. Okay, so continue, right? Please raise your hand if you get a final answer. Your answer will have something in, okay? Just like question C, right? Question C has 2m over 3, right? And then like question B, right? Something k. This one is something times m. All right, let's check the answer. Eric, what do you have? What's your final result?
I have 19m over 24.
Okay. Cindy, how about you?
I have the same.
Same. Donna?
Same.
Same. Okay. Tiana?
Same.
Okay. Kelly?
Same.
Okay. Anyone has trouble? Anyone get different? Or want me to go over this one? Okay. So you replace the m, right? And simplify the fractions. Okay. So final answer 19m over 24. Okay, so let's have an early break, okay? Because we have quite a lot to cover. I want to finish log today. So I will see you at 6:15, okay? I'll see you soon.